Imaginary numbers and complex numbers. So, in addition to having real numbers, there's also something called imaginary numbers. So, where numbers come from is when you have an equation where it doesn't necessarily have a number that you can use. So, for example, x squared equals negative 9 has no real solution. And the reason is because there is no number that when you square it, you get a negative 9 as a result. So if we try to take 3 and times it by itself, you end up with a positive 9, which isn't what I have here. If you try to do negative 3 times negative 3, you still end up with positive 9. And so no matter what you try to square, there's nothing that's going to give you a negative 9 as a solution. And so we say that this equation has no real solution. It does, however, have an imaginary solution. And so the imaginary number, the imaginary component I, comes from taking the square root of a negative 1. And so here is the definition of I. What this happens is when you have square roots of negative numbers. So if we look at number 1, simplify the radical. So I'm going to break this up into its factor tree. And I'm going to multiply negative 1 times a positive 25 to get me back to this negative 25 here. And I'm going to keep breaking down these numbers until I get a prime number at the very bottom of every branch. So negative 1 is prime. So 25, however, I can break up into 5 times 5. Now, both of these 5s at the bottom are, in fact, prime numbers. So when you simplify a radical, the pairs will go outside of the square root. So here is a pair of 5s. So 1 5 for the entire pair goes to the outside of the square root, and then you leave whatever is without a pair inside. So this negative 1 is going to stay inside the square root. Now, normally we would have to say there's no real solution, but now that I have the definition of the imaginary piece, I can continue. So this square root of negative 1, that actually turns into I. So instead of saying 5 times the square root of negative 1, we say that the final solution is 5I. So the square root of negative 25 simplifies down to 5 times I. Pause the video, see if you can try number 2. And here's your solution for number 2. So break apart negative 72 into negative 1 and 72, and then keep breaking down 72 into primes until you can't break down those numbers any further. So you should have had a negative 1, 3 2s, and 2 3s. Find your pairs. There is a pair of 2s here. Notice that the pairs do not have to be on the same branch. They can be on opposite branches. So a pair of 2s and a pair of 3s, and then there's a single 2 and a single negative 1. So 2 and 3 stay on the square root outside, and then the 2 and a negative 1 will stay in. But the square root of negative 1 is really an I, so that comes outside the radical as an I. So your final simplified version is 6I times the square root of 2. Now what if there's a number on the outside already? So number 3. So we're still going to start the same way. We're still going to break apart the inside number. So negative 1 times 9, and then I can break up 9 into 3 times 3. And so look for pairs. So I have a pair of 3s, and then I have a 1 that is all by itself. Well, the negative 5 on the outside is just going to stay on the outside, and he will be multiplied to my group of 3s that get taken out. And I still have square root, and then negative 1 will stay on the inside. But just as before, we know that the square root of negative 1 is equal to I. So this turns into negative 5 times 3, which makes negative 15, and then the square root of negative 1 is really an I. Pause the video, try number 4. And here's what you should have had for number 4. Now let's talk about the definition of a complex number. So a complex number is always in the form of A plus or minus BI. And so we have the real part of the number, which is A. So this would be the real part. And then B, since it has the I on it, that is the imaginary part. So really, you've been dealing with imaginary numbers this entire time. It's just the problem is the B has always been 0. So if you look at the second description, if B is equal to 0, then the number is just a plain real number. And let's think about that. If I have 0 here, 0 times anything is still nothing. And so if I have 3 plus 0i, all you really have is 3. And that's just the same real number 3 that you've been dealing with since elementary school. If you have b not equal to 0, so b is a 2, it's a 5, it's a -1, whatever, that means you have an imaginary number. So this will be something like 2 plus 4i. It could look like 2 minus 6i, something like that. That is an imaginary number. You have both a real part and an imaginary part. If you look at the last one, a equals 0, but b is something else, then this is called a pure imaginary number, and that's because you don't have the real part. If you have 0 plus 6i, well, that's just 6i. That's an imaginary number and only an imaginary number. So negative 7i is also a pure imaginary number. Now, the letter I, here's the key, super important. I is not a variable. It is not a placeholder for something that is unknown. I is equal to the square root of -1. So it acts like a variable though. Okay, what I mean by that is when you're adding or subtracting, you're going to consider like terms. So 2i and 3 are not like terms. So this is an imaginary number, this is a real number. So since they're not the same kind of number, you cannot add or subtract them. And so all you could be able to do is you could either write this as 2i plus 3, you could write it as 2i minus 3, depending on if you're adding or subtracting. You cannot actually add those together. However, on the other hand, 2i and negative 6i are like terms because they both have the I, the imaginary portion. So this I can actually combine up 2i minus 6i into negative 4i. Okay? Now, if you multiply, it's like multiplying a regular number or variable. So if you end up with I times an I, you end up with I squared. Now, here's a definition for what I squared is, because remember, I is not a variable. I has meaning. So I squared is actually equal to -1. And here's why. Remember that I is equal to the square root of -1. So if I take I and square it, that's like taking the square root of -1 and squaring it. Well, square roots and squares are inverses, so this square will undo that square root, and all you're left with is what's inside the radical, so which is -1. That's how this has been determined. So I squared is equal to -1. It's an important key in the next piece. Let's start working with these complex numbers. So number 5 says to simplify 8 minus I plus 5 plus 4i. Simplifying is not solving, they're different. So simplifying is just trying to combine as many like terms as you can, write this the simplest version you can. And so remember that there's a positive 1 in front of here that nobody writes. Same thing on this side, there's also a positive 1 here. So when you multiply in to get rid of those parentheses, 1 times 8 is an 8, 1 times negative I is negative I, 1 times 5 makes positive 5, and 1 times 4i makes positive 4i. Now that you've gotten rid of parentheses, you can use like terms to combine up some of these terms. So 8 and 5 can be combined to add up to 13. And also negative I plus a 4i are also like terms, and that adds up to 3i. You know you're finished when you can no longer simplify. You cannot combine or condense any further. So 13 plus 3i is as far as you can go because those are not like terms. For number 6, it's very similar. So on the first parenthesis, you have a 1 on the front, and on the second parenthesis, you have a -1 on the front. So let's distribute. So 1 times 7 is 7, 1 times -6 is -6i, and now we distribute the second -1. So -1 times 3 makes -3. -1 times -6i is a positive 6i. So when you're distributing positive ones, nothing changes. When you distribute negative ones, it changes all the signs inside of that parenthesis. Now we can start to combine. So 7 and -3 combine up to a 4. Then we have -6i and 6i, which actually combine to make 0i. Now that's a perfectly acceptable answer, but remember, we want the simplest terms. Well, 0 times I, 0 times anything, is just simply 0. Now this is no longer imaginary. Now you can add 4 and 0 together to make 4. Pause the video, try numbers 7 and 8. Here's what you should have had for 7 and 8. So for 9 through 12, now we're multiplying. And the reason why we know we're multiplying is because if we look in between this first term and the parenthesis, there is no add or subtract here in the middle. Same thing with number 10. There is nothing here in the middle of the parentheses, which means you're multiplying this parenthesis times this parenthesis. So for number 9, we're going to simply distribute just like we would a normal number. So 4i times negative 6 makes negative 24i, just like it would have if it had been 4x. And then 4i times I, well, 4 times 1 will make a 4. And then if you do I times I, you end up with I squared. Now, just because these both have i's does not mean that you can combine these up. Just like variables, if it doesn't have the same exponent, you cannot add the coefficients. So since this is I squared and this is just an I, these are not like terms. However, what we can do to simplify this is we can use that definition from earlier. And I squared is actually equal to negative 1. So what we can do is we can take out the I squared and we can replace it with negative 1. And then keep simplifying. So 4 times negative 1 will make a negative 4. And then we ask ourselves, well, can I combine negative 24i and negative 4? And the answer is no. Those are not like terms. We cannot combine them. Now, the standard form of a complex number actually has I at the back. So your final answer is actually negative 4 minus 24i. Make sure your i's are in the back. So number 10, we have 9 minus 2i times negative 4 plus 7i. And so this is your double distribution. Just like you would if these i's were x's. You're going to take the 9 times the negative 4 to get negative 36. Then we're going to do the 9 again times 7i to get a positive 63i. Now we're going to do the same process with the negative 2i. So negative 2i times negative 4 makes a positive 8i. And then finally, negative 2i times 7i will make negative 14i squared. Because remember that I times I makes I squared. Now that you've got everything multiplied, combine up what you can. So 63i and 8i are like terms. So you've got negative 36 plus 71i minus 14i squared. Now make sure you don't leave it this way because you want to simplify. Well, this is not as simple as it can go. I know that I squared is not actually an I. I squared is actually equal to negative 1. So what we can do then is we can make this a little simpler by getting rid of one of our i's. So we're going to simply replace I squared with negative 1 and then continue to simplify. So negative 14 times negative 1 is a positive 14. And then we can see maybe I can combine something else. And I see that, wait, look, this has no I and neither does this one. And so negative 36 plus 14 makes negative 22 plus 71i. This is the simplest that the expression above for number 10 will go because I can't combine 22 and 7i. Pause the video, try numbers 11 and 12. And here's what you should have had for your answers for 11 and 12.